Dear student, in previous lecture we discussed the linear programming problem, its mathematical formulation as well as the matrix representation of LPP and how to form the linear programming model and basic definitions required to form the linear programming problem. In this lecture, we will discuss the solution of linear programming problem by using the graphical method. As we know that there are 3 or 4 methods to solve the linear programming problem. First is graphical method, second is simplex method, dual simplex method, and big M method, or sometimes it is called as Charner's M technique method. Today we will learn the graphical method. Let us see the procedure of graphical method. Graphical method is generally used for LPP contain 2 or 3 variable. We use the graphical method basically in which the LPP contain 2 or 3 variable. In our syllabus we will discuss only LPP, solution of LPP by using graphical method for only 2 variable. Let us see the step by step method how to solve it by graphical method. Step 1 is consider all constraint as a equality, because student you know that the constraints are less than or equal to type or greater than or equal to type. Therefore in graphical method we consider all constraint as an equality. Second one, draw a straight line in xy plane. If it is in 3 dimension 3 variable, we will draw in a space corresponding to each equation and non-negative restriction. We draw a straight line corresponding to our constraint. Third step is find the feasible region, or it is called as a permissible region for values of the variable. Actually feasible region is the region which is bounded by the lines which we have drawn in step number 2. A region bounded by the straight line in step number 2. The step 4 is find a point in a permissible region in step number 3. According to our constraint, we find the feasible region and we see the region's extreme point, and we find out that point in a permissible region, and that points will give us the optimum value or solution of the given linear programming problem. Let's move to the problem. We have 5x1 plus 7x2 maximize z. Objective function is maximization type. Maximize z equal to 5x1 plus 7x2 subject to there are 3 constraint x1 plus x2 less than or equal to 4, 3x1 plus 8x2 less than or equal to 24, 10x1 plus 7x2 less than or equal to 35. All the variables which use in this LPP are non-negative. Before going to solution of LPP, I would like to explain about the types of solution. There are unique solution. The given LPP has a unique solution, unbounded solution, no solution, we see one by one by taking some example. Let first example is we see the unique solution for the given LPP by using graphical method. We have The objective function is maximize z is equal to 5x1 plus 7x2 and subject to these constraint. Consider these as also a constraint. Our step number 1 is consider the all constraint as a equality type. Therefore, we have the constraint x1 plus x2 less than or equal to 4. We write it as x1 plus x2 equal to 4. Don't use slack or surplus variable while convert the inequality into equality type in graphical method. Second constraint is 3x1 plus 8x2 less than or equal to 24. Obviously, it becomes 3x1 plus 8x2 equal to 24. And third constant is 10x1 plus 7x2 less than or equal to 35 becomes 10x1 plus 7x2 equal to 35. And x1 x2 greater than or equal to 0, also x1 is greater than or equal to 0 and x2 is equal x1 is equal to 0 and x2 equal to 0. This is our step number 1. Now in step number 2 we have to draw the lines of all these constraints 1, 2 and 3. Therefore we have to draw the line not only 3 but also 4 and 5. x1 is equal to 0 means x equal to 0 and x2 is our y-axis, x2 equal to 0. This is our step number 1, constraint as an equality. Now to draw all these lines we convert, we know that the this is x upon a plus y upon b equal to 1 is a two intercept form. A is called x intercept and b is called y intercept. We convert all these into two intercept form. Therefore, in our first constraint, we have x1 equal to x1 plus x2 equal to 4. Therefore, this constraint is x1 upon 4, divide the equation by 4 plus x2 upon 4. First constraint is x1 upon 4 plus x2 upon 4 equal to 1. Therefore, we have to draw the line L1 which is passing through the point 4, 4. Next constraint is 3x1 plus 8x2 equal to 24. Here divide the equation by 24 we get as x1 upon 8 plus x2 upon 3 is equal to 1. This is the line number 2. L2, therefore L2 is the line which is passing through the point, say 8 and 3. It is becomes passing through the point 8 and 3. And our third constant is 10x1 plus 7x2 equal to 35. Therefore, divide the equation by 35. We get x1 upon 3.5, x2 upon 5 equal to 1. Means we have to draw the line L3 which is passing through, say our third line is passing through the point 3.5 and 5. We draw the 3 line and obviously the line x1 equal to 0 means x axis and means y axis and x2 equal to 0. Therefore, consider the graph for this line. We draw the graph for these 3 lines passing through 4, 4, 8, 3 and 3.5 and 5. We draw the line, first line L1 which is passing through the point 4, 4. Second L2 line which is passing through the point, it becomes 8 and 3. Let us see. Passing through the point 8 and 3. The point is passing through 8 first line is passing through L1 is passing through the point 4 4. Second line passing through the point 8 and 3, and third line is passing through the point 3.5 and 5. Also x1 equal to 0, L4 line, and x2 equal to 0. Using the open board application, we draw the line. Go to the application, according to the point. We have the point 4483, therefore x-axis having the point 8. Let us draw the lines. Using the application in software. First line is passing through the point. Let's take again. According to point, we can move the graph. Our first line is passing through 4 4. This is our first line. Then second line is passing through 8 3. Then next line is 3.5 and 5. and 5. See the constant. We have all the constant is of less than or equal to type. Both three constants are less than or equal to type. Therefore, we give the name for this. This is line L1. L1 is this one. This is L2 and this is L3. Now for L1 the constant is of less than or equal to type. Therefore this is towards the origin. Second line is also on less than, second constant is also less than or equal to type, and third constant is also less than or equal to type. Therefore this is our feasible region. C. A region bounded by the line is you may draw again. Four 3 8 3.5 and 5. This is line L1. L1 is passing through 4, 4. This is L3 and this is L2. All the constants are less than or equal to type. Therefore, this is the reason for the line, and this is for L2, and we can say that this is our feasible region because we have given that x1 is greater than or equal to 0, therefore, and x2 is greater than or equal to 0, therefore this is our feasible region. We give the region, this is O, origin, which is 0, 0. This is the point A, which is 4, 0. Then our next point is, we can say that it is, if you can observe, it is, see, we don't know, say x1 and y1, we find it, and at a point OA it is B and it is C. At a point C we have 0, 3. Therefore this is our, the region bounded by the all line is a feasible region. This is our feasible region. See, the first line is passing through the point. See, the first line is passing through the point. See, the first line is passing through the point 4, 4. Second line is passing through the point 8, 3. First line is passing through, first line is passing through 4, 4. Our first line is passing through the point. We have the first constant of the line which are passing through the point 4, 4. Second is passing through the point first line is passing through the point 4, 4. Second is passing through 8, 3. First line is passing through 4, 4. Second line is passing through 3, 8. And third line is passing through 3.5 and 5. Say it is lies between 3 and 4. 3.5 is 3.5 and 5. We give the name to all line. The line passing through the point 4 4 is L1. Say it is L1. The line passing through the point 3.5u and 5u is L3. This is our constraint. According to our constraint, it is L3. This is L2. Now see the feasible region. The feasible region is the region bounded by the lines. The first line is less than or equal to constraint, therefore this is our region. For second line, it is also second line. We have also the region in this side. Third line is also in this side, and our x1 is greater than or equal to 0 and x2 is greater than or equal to 0. Therefore this is our feasible region. This is our feasible region. We give the name O to the extreme point of the region, O, A, B, C and D. We have given the name to the diagram O, A, B, C, D. Therefore O, A, B, C, D is our feasible region. And you know that at O, the coordinates of O are 0, 0. Therefore our maximize function, maximize Z is C. Our objective function is 5x1 plus 7x2. At O, maximize Z equal to 5x1 plus 7x2 becomes 5 into 0 plus 7 into 0, which is equal to 0. At a point A, you can observe that at a point A, the coordinates of A are 4, 0. Therefore objective function maximize Z equal to 5 into 4 plus 7 into 0, which is 20. Next point is our D. D. At a point D, the intersection D is the intersection of line L1 and L3. Similarly, C is the intersection of line L1 and L2. At a point D, D its coordinates are 0, 3. Therefore you can find here the maximize Z. Maximize Z is equal to, maximize Z is equal to 0 plus 7 into 3, that is 0 plus 7 into 3, which is equal to 21. We find the point of intersection of L1 and L3, similarly L1 and L2. The point of intersection of L1 and L3, L1 having the equation x1 plus x2 equal to 4 and L3 is 3x1 plus 5x2 equal to 35. Therefore multiply this equation by 3, it becomes 3x1 plus 3x2 equal to 12. And subtract from this, you get 5 minus 3 is 2x1 equal to 35 minus 10 to 23. We can see in the using the application, we will draw the line passing through the point. First line is passing through 4, 4. Second line is passing through the point 8, 3, 8 and 3. Second line and third line passing through the point 3.5 and 5. And according to constant, our first line, this is L1, this is the line L1, this is L3 and this is L2. According to constant, all constant are less than or equal to type. Therefore, you can say that this is first line, this is second line less than or equal to, third line is also less than or equal to, x1 x2 greater than or equal to 0. Therefore, the common region is the region here, means the extreme points are O, A, B. This is our B point. If you draw it on your graph paper or plain paper, you can easily see. This is our feasible region. See the feasible region. Using the software GeoGebra, I have drawn it. This is O, A, B, C. The dark portion is the feasible region. C. At O, at a point O, OABC is the feasible region. At point O, O is a origin, therefore it has a coordinate x1 equal to 0, x2 equal to 0, and our objective function is maximize z equal to 5x1 plus 7x2. Therefore, when we put the values x1 equal to 0, x2 equal to 0, the maximize z equal to 0. Similarly, at a point A, you can see that the coordinates of A are 4, 0. Therefore, the value of the at a point A is 5 into 4. At a point A, the maximize z equal to 5 into 4 plus 0 into 7. It is equal to 5 into 4 is 20 plus 0, which is equal to 27. See. Just a minute. A is, oh, not 4. Sorry. A is